This is by the time you reach this rule, you should be very familiar with the first two rules. So essentially, this one will be the rule number 3 for differentiation technique. So the name of this rule is called chain rule, and it is specifically for a function, for something that looks like this. So let me elaborate when do you use the chain rule first. So you use the chain rule when you got a function with a power. So that function here, typically most of the time, it can be an algebra function, but it can be a trigo function, which subsequently later on you'll be learning how to differentiate trigo. It can also be a logarithm function, or it can be an exponential function. So all these will be covered in the further differentiation technique. So at the moment, you are dealing with algebra with a certain power. So when you have a certain power, you will try to use this rule. Um, Maybe sometimes there's a bit of alternative. If it's a power tool, sometimes we can do some algebra expansion, basic expansion. Then we can use back our first rule. But let me just show you the idea first. So the trick about this rule is, right, there are 3 big steps. So if you remember rule number 2, rule number 2 is bring down power minus power. So here is almost the same thing. So bring down power minus power. So we add on a third step. You got to add on the part where you differentiate inside the bracket. So essentially, you are differentiating the function. You isolate the function in the bracket. So it is a portion inside the bracket that we're going to differentiate. So does that mean that when you're using this rule, you actually don't need to use your rule number 1, number 2? No. Most of the time, number 1, number 2 will be wrote into this rule. So let me show you an example. Okay, so typically the same thing apply. So we'll give a naming notation. So the function inside is x plus 2. So this is the function that is being inside. So later on, when we do the third step, I'm differentiating the x plus 2. So presentation-wise, this is how we'll do. So I'm going to apply my chain rule. So we got 3 things. So bring down power, and you minus power. So when you bring down power and you minus power, the function inside will stay inside. There's no change to it. Then this will be the third step, differentiate of the function that's inside. So the dx, you can think of it as it represents the word differentiate inside, or differentiate the function that is inside. So this is a function that is inside. So first step is to bring down the power. Second step is to subtract the power. So while you're doing that, nothing changed in the power in the bracket. The function doesn't change. So essentially, your first 2 steps are completely done already. So how are you going to execute the third step? So how will you differentiate x? So that should be your rule number 2. How should you differentiate 2? The constant 2. So that should be your rule number 1. So this whole thing contribute the third step. So if you differentiate x, you get a 1. If you differentiate 2, you get a 0. So all in all, the final answer will be this. So again, you do not need to do step by step. Essentially, when you get very used to all this, you will just be able to do a mental. So it's all right that you do a mental and straight away give the answer. So for part B, if you look at the function, what kind of function is in the bracket? The function that is in the bracket is a quadratic function, so it still falls under the algebra part. So that is a quadratic function. So let's execute the steps, the 3 steps of the chain rule. So bring down power. So the power is 6. Subtract the power. So while you are subtracting the power, the function stay nicely inside. The third step, you are differentiating the function. So the first two steps doesn't change anything. You're already done. So the part is to look at the third step. So what will you use to differentiate a 2? You will use rule number 1. And you will use rule number 2 to differentiate minus 3x squared. By now, you should be able to tell that differentiate minus 3x squared is just a minus 6x. So the third step is just a 0 minus 6x. So we organize them a little bit. So this algebra multiplied by 6. So that will be my dy dx. Okay, so in the next example, we are going to show the same thing. In the next example, it is still a quadratic function that is inside the bracket. So make sure you can identify. So what kind of function is in the bracket? So that is another quadratic function. So if you do a dy dx, bring down the power, subtract the power. So while subtracting the power, the function stay intact. Then now you do the last layer, you are differentiating the function that's inside. So no more power. We don't have to take the power 3 or the power 4. So we just isolate the function that's inside. So the first two steps will give a very nice algebra. So the focus is actually on the step 3. Maybe by now you can mental. You can mental how you differentiate this. So 1, formula 2, and formula 2. So maybe by now to you it's quite easy. It's 0 plus 1 minus 4x. So the final answer is, so usually I'll organize the function so that it look neater. So that will be the chain rule. So bring down power, minus power, differentiate inside. You need to execute the 3 steps in order. So you will need to see what kind of mistake you can make. Maybe here it will be easier, but if you go to example 2, where you start to have negative power or where you start to have square root, maybe it will get a bit more difficult. So for example here, so for part A, I got a fraction. So this fraction, will you be able to tell that, right, it's actually like this? So I need to use some of my indices. So the indices rule that I use here will be this. So you need to ensure that the number and the function is side by side. So let's execute our 3 steps. So bring down the power. In this case, that is a negative. The function inside doesn't change. It is a linear function inside. So when you minus power, you are still minus 1. So minus 3 minus 1, we get a minus 4. And then we need to differentiate the linear function that is inside. So I'm differentiating this function that is in the bracket. So with negative power, things somehow get a little bit more confusing. So what you can do is right here, this will be a minus 9. Here, you can actually return it first. Return it to the bracket format. Then you focus on differentiating the inside function. So if you just isolate the function that's inside, differentiating 3 is first formula. this will be the second formula. So by now, maybe it's also very obvious. So you get a 0 minus 4. So all in all, minus 9 and 0 minus 4, which is a minus 4. So gave me a 36 over 3 minus 4x power 4. So the three steps shouldn't change. The three steps is still the same thing, even with negative power. It can be a negative fraction also. For the power, it can be negative fraction. So in the next example, okay, there is a square root. So how do you handle the square root? Again, you got to change it to indices. Change using indices so that you got a power to bring down. So we will do a bring down power, which is a half, and I will subtract a power. So half minus 1, that is a minus half. And you differentiate the function that is inside. So isolate the function that is inside. So take a look, it's a linear function that is inside. So, okay, if you are looking at this part, this is the one that a lot of students are not very good with. This is a negative. So by right, a negative should be like this. Okay, then you focus on your third layer. So this should be rule number 2, then rule number 1. So you will get a 2 plus 0. So 2 plus 0 times half, essentially it will cancel off. And how will you write a power half? That will be a square root. Okay, so for part C, it's almost the same. If you realize for part C, it is also a square root. The inside is a quadratic function. So can you see it's a quadratic function inside? So dy dx, bring down the power, which is a half. Subtract the power, half minus 1 minus half. So the function inside shouldn't change. Third layer, you differentiate the function that is inside. So this is the function that is inside, the quadratic function. So again, there I got a negative power, make it back to the fraction. So this third step involves you using rule number 2, and rule number 1. So bracket it up. So differentiate x squared, 2x. Differentiate 2x is a 2. So if you look carefully, this thing can be factorized. It will go up to the numerator. The power half is a square root. So there is a cancellation where you can simplify. So that is our chain rule. Okay, so bring down power minus power, differentiate inside. So bear in mind, this one is meant for a function with power. The power can be negative, the power can be fraction, or it can be negative fraction as well. So the function inside most of the time will be algebra. So like I mentioned just now, it can be changed to trigo. You will see that under the trigo section.